Okay, guys, welcome to your first maths lesson of term 5. What we're going to start with today is a little bit of a review of what we started last term when some of you didn't have access. So we're going to repeat a section of the chapter just to make sure that everybody's caught up and everybody perfectly understands. And then once we've done that, we'll move into the newer materials. So to start off, I'd like you to complete this fluency and warm-up section. I need you to pause the video, though, while you do those, because obviously my video will keep going through the slides, but you need time to pause and to do these questions. Okay, so please can you do that now? Press pause and complete those questions. Then we'll go through the answers together. Okay, guys, thank you for pausing and for completing the questions. Okay, just give me a moment while I get set up for you. There we go. Okay, so I'm going to use the visualizer so that we can go through the different parts of the learning today, but also to take up the fluency questions. So let's take a look. So the first question said, what does perpendicular mean? Okay, well, to help answer this, I think a diagram would be good. There's a line segment, and perpendicular actually means at a right angle to something. Okay, and we use that symbol there, that little square, to mean a right angle. Okay, and a right angle is 90 degrees. All right, so to answer a question about what does perpendicular mean, it's perpendicular means at a right angle to another object, or in this case, line segment. Okay, all right, but the key bit there for the definition is that we are at a right angle, okay, to the other line or object. Right, so that sorts out that bit of the question. Then it says, what does congruent mean? Okay, well, actually, congruent means exactly the same. And we are talking about shapes. So it means that two shapes are exactly the same. Now, you might wonder whether or not the shapes can turn around. Absolutely, they can. Okay, so if I use the inside of this to create my triangle, well, that triangle is going to be exactly the same as any other triangle I draw using this. Okay, but it doesn't really matter what direction they're in. Okay. All right, so congruent means that the triangle is the same, but its position can change, or the shape is the same, but its position can change. Okay, I chose a triangle because that was easier to draw for you. All right, so hopefully that makes sense, but the same is really important. If I drew a triangle with the same relationship of sides, but it was bigger, then we would say similar. We wouldn't say congruent. Okay, so that's question 1. Question 2 says, work out the perimeter and area of each shape. Okay, well, the first shape is a square. They're a little bit naughty. They probably should have, when they drew the square in 2A, they should have shown you that it was definitely a square. And the way they would do that is to use little markers to show you that each of the sides were the same as each other. So they should have done something like this, which would have said to you it's definitely a square because they're all the same, and each side length is 5 centimeters. When we do perimeter, we add up the sides, so the perimeter of this shape, since there are 4 sides, would be 4 times 5, which is equal to 20 centimeters. Okay? When we look at part B, we've got another rectangle. I say another rectangle You might be questioning that because we just had a square. Well, a square is a special type of rectangle because it still has 4 sides and it still has all right angles, okay? It just happens that all the sides are the same. Right, so for this one, we had 2.5 centimeters for the width and 6 centimeters for the length. So to get the perimeter, remember, we have to have every single side. So you have to remember that this is also 6 centimeters, and this bit here is also 2.5 centimeters. So we have to add that on. Can we make that easier? Well, there's 2 of the 6's. So when we do the perimeter, we can do 2 times 6, and then add on 2 times the 2.5, because of course there's 2 widths. And that gives us 12 plus 5, which is 17 centimeters. Okay. And that brings us to question 3. Now notice for each of these, oh sorry, no it doesn't. Forgot part C, apologies. All right, so let's look at part C. Right, so, that's interesting. So in part C, they've given us letters. So what they're saying is come up with a formula, okay, without actually asking you to. Okay, so they've used an L and a W. Well, again, we need to make sure we include all sides in the perimeter. So that's the W and that's the L, okay? And you'll notice there are 2 L's and there are 2 W's. So we could say the perimeter is L plus W plus W. But we can simplify that because there are 2 L's. We can say that that's 2L plus 2W. And what we've actually done is come up with a formula for the perimeter of a rectangle. So that's quite a clever question. It forces you to come up with a formula without actually asking you to. Okay, so the perimeter of a rectangle would be 2 lengths plus 2 widths. Right, so we move on to question 3. And in question 3, we have a compound shape. You definitely need to draw these. Okay, we're going to be finding first the perimeter. And the second thing we'll find is the area. Okay, but when you have these questions, you have to make sure that you draw them because you have to be able to write on them. And if you don't draw them, it doesn't really help you out. Okay, it's not to scale, so don't worry too much about your measurements here. It's just the shape we need, and then we label the shape with the sides that they've given us. Okay, so don't worry so much about it being perfect. Right. So now at this stage we label. So they've told us that this is 6. Now I know these are all centimeters in the question, but I'm going to leave that out only because it kind of gets in my way. Yes, with these arrows. All right, as long as we know we're dealing with centimeters, that's okay. And we have 10 up here. Okay, and then here we have 9. Okay, so they've been very nice to us. They've given us all of the sides. Sometimes they don't, and we have to work out some of them, but that's fine. We've got them all here. So in terms of your perimeter, we just need to add them all up, but make sure you tick as you go. Okay, so for part A, we're finding the perimeter, and that's going to be equal to 10 plus 9 plus 15 plus 6 plus 5 and then plus 3. Okay, so double check 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 sides. Okay, lovely. And so I use some mental maths here. 10 plus 15 is 25. So that's those 2. Plus 5 is 30. So we've got 30 plus, then we can do 9 plus 6 is 15 plus a 3 is 18. So we've got plus 18, which gives us 48. Okay, so never be worried about splitting things up and doing them in sections. As long as you keep track of where you are, that usually makes it easier. All right, and then if we look at part B, which is the area, I actually have 2 rectangles joined together. So how you split this up is up to you, but I prefer this way, so that's where I'm going to split it. Okay, and I'm going to call this area 1, and I'm going to call this one area 2. Let's deal with area 1 first. It's fairly clear. We can see that the width here is 5 and the length is 6. Okay, so that's going to be 6 times 5, which is 30 centimeters squared. Don't forget, because it's area. If I now look at area 2, I don't want to use the 15 because that includes that second rectangle, and I only care about this one now, so we're not going to use that. Instead, we're using the 10 because that is your width of that rectangle, A2, and 9 because that's the length. Okay, so 9 times 10, which is 90 centimeters squared. So finally, to get the total area, we're going to add those together, and the total area is equal to 90 plus 30, which is 120 centimeters squared. All right, so hopefully that makes perfect sense to you. And let's move on. Right, so what I want to focus on next with you is how we actually derive the formula for the area of a triangle. I think a lot of you already know what it is. I've got it here. Okay, area is a half of base times height, or base times height divided by 2. But why? Well, here we have a rectangle. Now, we know that the area of a rectangle is length times width. So we could say that that's the length and that that's the width. Fine. And I think you might note that I could cut this in half this way and make 2 triangles. Okay. Now, those 2 triangles have the same area. It's half the shape. So if we just looked at one triangle, we would agree that that's half the shape. But when we deal with triangles, sometimes they're different shapes, and so we use a base and a height, okay? So we could change our lettering so that that's the base and that that's the height. And if we do that, and since it's half of the rectangle, then the area of the triangle is going to be equal to a half times this original length times width, which we now know is a half times the base times the height. And that's because we've changed our lettering. That's all. Okay, we've decided in triangles we're going to call the bottom of the triangle the base and the perpendicular height the height. Okay, and that is why we have that. And then you might wonder, well, why didn't we just stick with length and width? It's because some triangles, of course, aren't going to be right angle triangles like this one. They're going to be triangles like this, like in our diagram there. Okay, if I have a triangle like this, well, actually, yeah, this is my base. Okay, but I care about this perpendicular height, which, of course, in this example, is inside the triangle. So that would explain why we have to make sure that that we use base and height, that we don't use length and width, okay? Because otherwise it wouldn't make sense for the shape of a triangle. There is one other situation which we don't get very often, but it does come up, so let me show you. And that's where here's the base, but the perpendicular height actually sits outside of the triangle because the triangle is slanted, okay? And so that would be the height. All right, so in any of these cases, you would be doing a half times the base times the height, which we could think of as instead being the base times the height all divided by 2. If that's easier for you, that's fine. And of course, that would be the area of our triangle. So hopefully that helps and that makes sense. You can pause it and take notes, okay? That would be really lovely. And then that way you definitely have all of that information in your notes for when you do the questions. Okay, so pause the video so that you can do that and take notes on that. And then we'll move on to the questions. Okay, thanks guys. All right, so what we're gonna do is I'm gonna make that full screen again for you. Okay, so that's a little bit easier. There we go. Okay, so if you could do question 4, please. Pause the video. Okay, thank you for doing question 4. Here's the answers. Oh, sorry, not yet. Do question 5. Pause the video. Okay, thank you for doing question 5. Right, let's go through the answers to question 4 and question 5 together. So for question 4, for part A, you should have had 2 squares. For part B, you should have had an area of 8 squares. And for part C, 9 squares. For question 5A, part 1, the area of A was 6 centimeters squared and the area of B was 24 centimeters squared. The answer for part 2 was 2, and for part 3, the area of A was 3 centimeters squared and the area of B was 12 centimeters squared. Now that makes sense because these were triangles, which were half of the rectangles, okay? Now for part B, you should have gotten 30 centimeters squared and then half. For part C, something in word description about what you're doing, okay? So multiplying the base by the perpendicular height and then dividing by 2, that's perfectly fine, okay? Or something very similar. And our formula, okay, which we've gone through how to derive now, was this for part D, okay? So hopefully we were okay with questions 4 and 5. Okay, you can always go back and look at them again and redo them if you need to, okay? Right. If you didn't get a chance to write down the formula before, you can pause the video now, okay, and copy down the key point, but it is the same as when I derived it with you, so if you've already done that, then you don't need to. Okay, and now I'd like you to pause the video and complete question 6, okay, which are areas of triangles. Notice H is one of those slanted ones. Okay, so be very careful when you do H. Your base, okay, what are you using for your base? In this case, you are using 4.2, and your height, you're using 6.7. Okay, so I've helped you out a little bit with that one because it is slanted. Okay, we've got 4.2 as our base and 6.7 as our height. Okay, so now pause the video and complete those questions. Okay, guys, thank you for completing those questions. All right, the answers were 6A was 48 centimeters squared, B was 100 centimeters squared, C was 45 centimeters squared, D was 88 centimeters squared, E was 28 millimeters squared, F was 39 meters squared, G was 6 centimeters squared, and H was 14.07 millimeters squared. Hopefully you got your units correct. Sometimes when we get used to writing centimeters squared, we forget that they change to things like millimeters squared and meters squared. So just correct that if you got that wrong. Any of them that you got wrong, just go back and redo them using the formula, and you maybe had a calculator error. You should get them right. Most of them you didn't need a calculator for. Okay. In the assignment, you also have an extra pack to do with answers provided. So can you also complete those now? And then that's the end of this particular part of the lesson. Okay, well done on that. Your next lesson will come out on Wednesday. Okay, take care, guys. Bye.